Geometry with Ms. Connolly. Today we're going to talk about angle and arc relationships. So in this little installment here, our objective, we're going to be able to apply angle-arc relationships, we'll learn about that, to find missing values. So we're going to be doing things like solving for x, whether x is an angle or an arc or whatever the case is going to be. Alright, I'm going to erase this so we can save some room. You can write this down, you can pause and make sure that at the end of the lesson that you can meet the objective. Alright, we've got some keywords to go over today. We're going to be using them a lot. Vertex you've heard before. A different color. The vertex of an angle is the point of the angle. We said that these are the legs. We're pretty familiar with that by now. But the vertex is the point where the two legs meet, and actually that's what we're measuring, where the vertex is. An inscribed angle, we'll talk about when the vertex is on the angle. It's on the side of the angle, and the bottom is on the top. The vertex of an inscribed angle is going to be somewhere along the edge of the circle. In a central angle, the vertex is going to be right in the middle, in the center. So we can make center on that one. So these are the two ones that we're going to focus on today. We'll talk about some others in the coming weeks, but for today, as our intro, we're just going to talk about inscribed angles and central angles. So something that you might see. Something that you might see in a math problem like this, I don't know, we have our circle, and we have a central angle. We have an angle whose vertex is in the middle of the angle. And I don't know, let's say that they tell us that the measurement of the angle is 45 degrees. Keeping in mind that in a whole circle, all of the angles that they give us are going to have to add up to, hopefully you said 360 degrees. Same thing with the arc. All the measurements of the arc are going to end up having to equal 360 degrees as well. So if we have a problem like this, it might give us 45 degrees, and we have to solve for x. The first relationship that we're going to go over is for central angles. Or in a couple different ways. Oops. The measurement of the angle, or symbol for angle, is congruent to, just like in proofs, we're still using the term congruent for all of this. Is congruent to measure of the arc. That being said, what would the measure of the arc be? Hopefully we said 45 degrees, because we know that congruent means the same. Means equal, that's fine. And again, if you find yourself not remembering the word congruent, it is totally acceptable for you to say the measurement of the angle is equal to the measurement of the arc, or the measurement of the angle is the same as the measurement of the arc. Whatever is mathematically correct and clearly communicated, just like we talk about in class, it'll work, as long as somebody can understand what you're saying. Alright, so there's that one. There's our first relationship. The measurement of the angle is equal to the measure of the arc, is congruent to the measure of the arc, is the same as the measure of the arc. Whatever makes it most easy for you to remember for now. Now that my erase is on the floor, take a minute, pause the video, write that down, and we're going to move on to the next one. Oops. Do this one in pink. Now let's say you have an inscribed angle. Again, we talked about inscribed angles being that the vertex is on the side of the angle, not in the middle. Alright, so let's call this one, let's make this easy on myself. We'll say that this is a 50-degree angle. Now I'll tell you to begin with that it's not going to be the same anymore. The measurement's going to be a little bit different. The rule for inscribed angles, and we'll actually write this one out in notation like you might see on questions. So the measure of the arc the measurement of the arc is 2 times the measure of the angle. Or alternatively, the measure of the angle is 1/2 the measure of the arc. Makes enough sense, right? Whatever we have here, this is going to be twice as big. Whatever we have here, it's going to be half the size of it. So if this angle is 50 degrees, what kind of arc do we have there? I'll give you a minute to think about it. Hopefully you said 100 degrees, because we know that 50 times 2 is 100. You know. All right, so take a minute, pause the video, write this one down, and maybe we'll try to get into some examples that might not be so clear to see.